Hi, I'm Rob, and I'd like to welcome you to this video where we'll look at Retrieval-Augmented Generation, or RAG. We'll discuss why it matters and how to build a pipeline from scratch using Jupyter Notebooks with OpenAI for embeddings in chat and ChromaDB for the vector store. And we'll walk through the full flow, from loading and chunking documents, embedding, retrieving, and generating answers. Plus, we'll look at concrete examples like citations and chunking strategies. So with all that out of the way, let's get started. First, I want to point out the README, which lists some prereqs you'll need, and specifically an OpenAI API key. So if you don't have one yet, head on over to platform.openai.com/API-keys, sign up, then follow the docs to create your key. You'll need to put it in the .env file in the demo folder, as we'll see shortly. Under the prereqs, you'll see the setup and run sections. Go ahead and follow those steps after you clone the repo, and you'll be all set to follow along here. Now, before we jump into the code, I want to point out a markdown file in the data folder. This has information for a fictitious company named AI Agent Ensure that we'll use as a data source for our RAG app. Now, in the demo folder, you'll see a requirements.txt file, which will be used when you execute the pip install command in the setup instructions, and it will install OpenAI, ChromaDB, and other libraries we'll need for the demos. Additionally, there's a .env.example file, which you'll want to copy and save as a .env file, and then paste in your OpenAI API key as you see here. And there's a RAG utils Python file, which is used by both notebooks in this section. It defines a data file variable and assigns the name of the AI Agent Ensure markdown file, then returns the path to that file from the data folder. The load document function loads that markdown file, then returns it, and the chunk by sentences function takes a document and it splits that document into sentence-based chunks, which we'll see implemented in the notebooks. Chunk by tokens also takes the document, the max number of tokens we want to chunk by, and overlap tokens. And if we don't pass these values, the default for max tokens will be 80 and 20 for the overlap. So this function will split the document into fixed size token chunks with overlap using the tick token library. So here we'll get the encoding for tick token and then use it to encode the document we passed in to get the tokens. Then we'll loop through the tokens, getting token chunks, decoding the chunk, then appending it to the chunks list. And when that's done, we'll return the chunks. The embed function will embed the text using the OpenAI library, ensuring we have a client, then calling create on client embeddings, passing our model and the input text, and then returning the embeddings. And finally, the build index function takes the list of chunks, a collection name, a client, and the embedding function. And this will build a ChromaDB vector store from the chunks, and it returns the ChromaDB client and the collection. Again, this is a shared utility Python function that we'll see implemented in both notebooks. Now let's open the first notebook. So in this first notebook, we'll introduce why RAG matters by answering the same question with and without retrieved context. And then we'll walk through a minimal RAG pipeline, where we'll load a document, chunk it, embed it, store in ChromaDB, then retrieve the top K chunks, which we'll look at shortly, and finally prompt the model to answer from that context. Now, to get started, we have a setup cell where we'll load .env and OpenAI libraries. We'll call load.env to load the values from the .env file, which is our OpenAI API key. Then we'll call OpenAI to get an instance of a client. We'll set the chat model to OpenAI's GPT-4o mini, and we'll create a variable for top K, setting its initial value to 5, which we'll look at shortly. So let's go ahead and run the cell, and then we'll look at our first demos. So here we're creating a variable called context, which is setting it equal to a string, which has the product portfolio for AI Agent Ensure. Then we're defining a question. What products does AI Agent Ensure? And now we'll call the chat completions create API, setting the chat model and the messages equal to the user role and the content equal to the question we defined above. We'll set temperature to 0, and from the response, we'll grab the 0th element in choices, its message, then content. So let's go ahead and run this. Oh, and it looks like I forgot to run the cell above, so let's check that out. Yep, sure enough. Now with context and question defined, we'll run this cell again. And in the response, we see it's pretty clear that the model doesn't know what AI agent ensure is. Now let's pass the context in a prompt. So here we have a function, prompt with context, which we pass the context and the question, and then return a string, which starts with, use only the following context to answer the question. If the context doesn't contain the answer, say so. We'll pass the context and the question to the chat completions create API, setting the content equal to calling prompt with context, passing the variables we declared above, and then print its response. So let's run this. And here we see the model has replied with the appropriate answer. Now let's pass a question to the model that isn't contained in the context. So we'll ask who won the 2025 F1 Constructors Championship. And when we run this cell, as expected, we see the model's reply that the context doesn't contain the answer to the question. Now let's build a minimal RAG pipeline, or we'll pass the same question to the model using two different values for top K, which is a sampling parameter in LLMs that limits the selection of the next token to only the top most probable candidates, so the top K candidates. We'll start by loading the load document, chunk by sentences, embed, and build index dependencies from RAG utils. Then we'll load document, which we actually already did above. Then we'll chunk the documents, passing the doc to chunk by sentences, and then print the values again. And now we'll populate the Chroma client and call variables, which is the ChromaDB collection, by calling build index, passing it the chunks, a collection name, and the client, which is our OpenAI client. Now we'll declare a function, run RAG query, which takes the call, question, top K, and the client, and we'll retrieve the top K chunks, build the prompt with context, and then returns the answer with the retrieved chunks. So here we'll embed the question by passing the question and the client to the embed function and set the results equal to calling query on call, where query embeddings is equal to the embeddings we just created, and results is equal to the top K value we passed in. Then we'll retrieve the first document from the results, save that, and then set our context by joining a new line to what was retrieved. Then we'll pass the new context with the question to the prompt with context to get the prompt that we'll pass to the chat completions API. Then we'll return the message content and the chunks retrieved. So let's go ahead and load this function. And now we'll run our two tests. First with top K set to 5. And we'll see that the response when top K is set to 5 indicates that the context does not specify the exact products offered by AI agent ensure. Now let's run with top K set to 8. And we see our expected response. So the takeaway from this is that the retrieval quality and K directly affects whether the LLM can answer the question. So setting too small a top K value, you may not return the chunks required to answer the question. Whereas a larger K improves the recall, but it adds noise and cost. So you'll have to play around with the top K value based on the data you fed into the vector store and the response you need to receive. Now, the second notebook runs concrete RAG examples using the same pipeline code defined in the RAG utils Python file used in the prior notebook. Now, in this notebook, we'll see demos of a single document Q&A implementation. We'll create answers with in-text citations, which are converted to chunks, and how different question types like underwriting and target market impact the response. Then we'll take a quick look at the differences between sentence versus token-based chunking. So let's run the setup cell to get started. Now, before moving on, I'll point out that doc is populated by calling load document, chunks is populated by passing the doc to the chunk by sentences, and the Chroma client and collection variables are populated by calling build index, which takes the chunks. And as you'll recall, these functions are defined in the shared ragutils Python file as we see here. Now let's take a look at the first example, where we'll query the document asking what products the company offers. We'll pass the question to the embed function, then call query on the Chroma collection, setting the query embedding and top K. We'll get the retrieved document and set the context. Then we'll build the prompt, injecting the context in the question, then call create, passing the prompt. So let's run the cell, and we see the response. Now let's look at returning citations in the model's response. Here we'll ask a new question, then set the numbered chunks equal to a string where each retrieved chunk is prefixed with the ID. For example, chunk 0, chunk 1, so the model can refer to the chunk in its answer. Then we'll create a new prompt, instructing the model to return the citations, inject the context in the question, then execute. And we see the response with the chunk. Now let's ask another new question. And we see the response is correct, proving that we're able to retrieve the proper information for the question using the same index. Finally, let's look at sentence-based chunking versus token-based chunking. First, we'll import chunk by tokens from ragutils, which uses tick token to split the document into fixed size tokens. Then we'll chunk by sentences and chunk by tokens and print the samples. And we see the response based on the chunk and overlap sizes. And now we'll build separate indexes for the same question, starting with passing chunks sentences, then chunks tokens. Then we'll get the query embeddings and pass them to the collection with chunks and the collection with tokens, and get the return documents. Now we'll declare a function which takes the chunks and the question, creates the context, injects the context and the question as usual, then calls the chat completions API. We'll get the answer for the sentences and the tokens and then print the results. So let's run the cell. And we see the response, which shows that the model lists the AI agent ensures target segments, which come straight from the retrieved context. So the answer is grounded in the document, which is the point of using RAG. So that concludes this video on RAG and building a RAG pipeline. If you found it interesting, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. In the next video, we'll build a Streamlit UI to interact with the pipeline to retrieve information from the vector store. Thanks for watching.